Hello, my fellow learners. Our discussion now is all about polygons. This presentation is just modified by Lisa Palin, and I will be the one to discuss with you the thorough, in-depth learning for this topic. So hold on, just keep on watching. Now, when we talk about polygon, its definition is it is a closed figure formed by infinite number of coplanar segments, so that its segments exactly two others but only at their endpoints. So we have it here, this figure, another figure, and now have here, this figure is not considered now as polygons because this, as you can see here, it is not closed, though this one is closed, but there is some other things that we're going to consider how to become this one as a polygon. Okay, then we now have here another set. This one, these figures are polygon, so we could get their end, but we could just get their endpoints. Okay, but here in this figure at the left, we cannot give the endpoints of this because there is an intersection wherein this must be their endpoints. So we could not consider this one anymore as a polygon. So this one also is not a polygon because it is not on the same plane. They are not coplanar, but they lie on the other points are lie on the other plane. Okay, but this one is a polygon because, as you can see here in this figure, it is touched only at the top of the plane that we have. So we are now able to classify the certain polygon that we have. So we could see a regular polygon, a polygon in which all angles are congruent and all sides are congruent also. So we could now see that one as a regular polygon. That's equilateral polygon as we say, because the angle is equal, same as its lateral. When we say lateral, it is a side, so it is also equal. So we see here this figure is a regular polygon because the sides are equal, then same as the angle are also equal. A regular polygon is a polygon that is not regular. So we see this figure. It is not regular. So that one is called an irregular polygon. So another thing that we're going to consider is what we have here, the so-called concave polygon. When we say concave, and the other one is convex polygon. So when we say concave, it's just like a cave. It has indentations. A polygon that has at least one angle that measure more than 180 degrees or reflex angle. A polygon which there is a line containing a side of a polygon and a point interior of the polygon. We also have convex. It has no indentations. A polygon with no angles measure more than 180 degrees. So as you can see here, if we're going to attach a certain point in this case, then if we're going to touch out this and it go the line here, then if ever it will touch outside, that one is what they call concave polygon. And then if we and the other one, if we're going to pinpoint any points inside the polygon, then if we're going to touch that one there, then the certain point is never out from with a given figure, then that one is what you call it convex. So that is another set of difference in dealing with how to identify the convex and the concave. No line containing a side of the polygon, okay? A side of a polygon that contains a point in its interior. So that one is concave convex. Then we say a certain polygon, it has a certain meaning. If we have three sides, say three-sided polygon, four-sided polygon, and so on. So if we have three-sided polygon, we name that one triangle. If we have four-sided polygon, we name that one as quadrilateral. Five-sided polygon is a pentagon. Six-sided is what you call hexagon. Seven-sided is what you call heptagon. Eight-sided, we now have to name that one as octagon. Nine-sided is nonagon. Ten-sided is decagon. 12-sided is we have dodecagon. N-sided is n-gon. Okay, so that is then we also have any other things, any other sided polygon wherein we could name it, we could name that one as we go through. Diagonal of a polygon, a segment connecting non-consecutive vertices of the polygon. So we could choose this one. This one is one of the vertices that we have. This one here, another one. This one here is one of the vertices. This one. Then take note that if we're going to connect the diagonal of a polygon, it must not be a non-consecutive. So it must not be consecutive. So if we could pick this one and this one here, this one and this one here, then if we're going to connect that one is considered now as a diagonal. Then another diagonal that we have is this one and this one, if ever, but not to the point that we are going to intersect them both. Okay, then we also have interior angle of a polygon. Interior angles of the polygon are the angles inside the polygon formed by two adjacent sides. So we now have that. For example, we have here a triangle ABC has interior angles. So angles ABC, we have here angles ABC, ABC, and we have this. Triangle BAC, BAC, we have here this one. Angle BCA, BCA, so we have here this one, here. These are the interior now of the interior angles of a certain polygon, namely it is a triangle. The exterior of the polygon. The exterior of a polygon now is it is an angle that forms a linear pair with an interior angle. It is an angle outside the polygon formed by one side and the extended side of the polygon. So by the way, when we talk about linear pair, it is the sum of the two angles the sum of the two adjacent angles measure 180 degrees for a straight angle. So in this case, we now have here this one and this one, which is what they call it as straight angle. So they are now linear pair, and somehow the exterior angle now can be formed angle ACD. Okay, the angle ACD is what we call our exterior angle of the said polygon. We now have that one. For example, triangle ABC has exterior angle, which is angle ACD. It forms a linear pair with pair ACB inside. Okay, so the interior two angle A and angle B are other interior angle. What is the sum of the measure of interiors of trigons or the triangle? So the sum of the measures of the three angles inside the triangle or inside the three-sided polygon is 180. What is the sum of the measures of interior angles of a convex four-sided polygon? So we could say 405.93 degrees, 65.52 degrees. So we could say that one there if we're going to measure. So 180 plus 180 degrees, and that is 360. So if you're going to connect two vertices, then you can form a diagonal. So we could form now one triangle and another set of the triangle. So therefore, one set of a three-sided polygon with that is triangle measures 180 degrees. And then since we could form now two triangles in a quadrilateral, so we now have two 180s. So 180 plus 180, and we have now here 360 degrees as the sum of the four-sided polygon. How about five-sided polygon? So in a five-sided polygon, so we now have here um, a certain measures. So we have to connect one diagonal here, two diagonal in the five-sided polygon. And so we could now form 1, 2, 3 triangles. So we now have here three 180s. So 180 plus 180 plus 180, and that is 540 as we know it. So therefore we now have the sum of the measures in the convex five-sided polygon is just 540. Okay, what is now the sum of the measures in interior angles of the six-sided polygon? What do you think? Okay, so we now have here another set of diagonals. So we have here 1, 2, 3, four set of triangles. So we now have here 720 as the sum. Okay, n-gon. The n-gon now, the sum of the n-gons of the interior angles is what we have, n quantity n minus 2 times 180. So take note with that. Okay, so this is now the table that presented as we have it here previously. So in a triangle, we have here 180. Quadrilateral, we have here 360. Pentagon, which is five-sided polygon, which is 540. Hexagon, which is 720. Then the n-gon is n minus 2 times 100. What is the measure of each interior angle of a regular three-sided polygon? So since we now have here as the sum which is 180, then it is just a regular polygon. So when we say regular polygon equals equal angles, so we have now three equal angles, then 180 divided by 3, and that is 60. So in each angle interior measures 60 degrees. Okay, next is what is the measure of interior angle of a regular four-sided gun, and that is 90 degrees. Okay, we are going to divide it by 4. Five-sided, we have here 540 divided by 5, and that is 108 degrees. Okay, six-sided polygon, so we now have here 720 divided by 6, and that is 120 rather. Okay, the measure of the interior angles of a regular six-sided polygon, and that is hexagon, it measures 120 degrees. Another one for the n-gon is we have now here n minus 2 times 180 divided by the number of So n here is the number of sides of a certain polygon. So divide by n. What is the measurement of the n-gon? So we now have here in a regular polygon, which is triangle, so 60, quadrilateral 90, pentagon 108, hexagon is 120, and then the n-gon is the sum of the polygon divided by the number of side sides of a certain polygon. What is the sum of the measure of the exterior angles of the three-sided polygon? So since, as I said, when we talk about exterior angle of a certain polygon, it should be it should be a linear pair. So we have here, it forms a linear pair. So therefore, we now have here this is the interior, so this is the adjacent of this is the what we call its exterior. This is the interior. Its exterior now is this one, then the other one is this one. So we now have three angles to be formed. So take note that the sum of the measures of exterior angles is equal to 360 degrees. So we now have here, okay, so if we're going to have this, so the green part here is what they call 360, so the outside layer of the quadrilateral. In the pentagon we have here, so we now have 360. In the hexagon, so we now have the green part here. So if we have that one, so it measures 360 degrees. So the measure now of the n-gons, the sum of the measures is 360 degrees. Yes, it always 360 degrees no matter what n value that we have. So all the polygons exterior, each sum of the measures of exterior is 360. What is the measure of the exterior angle of a regular three polygon? Exterior angle of regular regular three-sided polygon. So we now have here 360 divided by n, and that is 120 because the number of sides is 3. So 360 divided by 3, and that is 120. So in the four-sided polygon, the regular four-sided polygon, we now have here 360 divided by 4, and that is 90 also. Okay, and we also have the five-sided polygons, which is, so 360 divided by 5, which is 72, because the regular here is 108. 108 plus 72 is 180. The regular six-sided polygon measures 60 degrees because the regular now is 120. So if we're going to identify the exterior angle of the regular polygon, we now have to divide 360 by n. Okay, what is the measure of the exterior angle of the regular n-gon? So we have this table. So we have now 120 in the triangle. We have here 120. The quadrilateral is 90, 72 for the pentagon, 60 for the hexagon. Then for the n-gon, we now have here 360 divided by n. So for a convex polygon with n sides, we now have here n minus 2 times 180, knowing the measure of the interior angles. The sum of the measure of the exterior angle is equal to 360. For the regular polygon with n sides, is the interior angle is n minus 2 times 180 divided by n. Then if we have the exterior angle is 360 divided by n.